Welcome everyone to another episode of our Let's Make a Game project. I'm really overwhelmed by the response I'm getting from this series. I'm really happy about it. I'm enjoying this so much. Today we are actually gonna take care of the camera movement. We will be able to pan around and we will be able to zoom, and hopefully it will go smoothly. Okay, let's not waste any more time and get right into it. What we have so far is really nice, I have to say. We have a loading bar, we have a world which is more or less randomly generating, of course on a simple level just yet. We might want to add the trees to our dev GUI, but other than that there's not much to do. Of course we want to have some mobility, which is normal with a settler slash civilization game top down. We want to be able to steer the camera. This is going to be today's topic. We want to be able to pan around, we want to be able to zoom, and hopefully we can do this in a smooth way. In order to achieve that, we are going to open up our heart and we want to create a new script in the step event. For that we are going to actually create the script outside of it, and we're going to call this script camera movement. Also give this a proper title, just like that. We're going to save that and make sure it is attached to our step event. Camera movement, okay and okay. We're going to open that up and actually get to programming. Now the camera movement is quite of a delicate thing. I had to test out a few methods in order to choose the best for my purposes. So we're just gonna kind of wing it and see with what we will end up. So first of all, I want to be able to pan around in all directions. So let's just start with the right direction. We're gonna check for a keyboard press just by using the keyboard check command, and we're gonna check for the right arrow key. Later on, of course, we're also gonna program in WASD, but for now that's fine. And we're actually gonna leave it at that for now. We're gonna take one step at a time. So if we press down the right arrow key, we want the view X position of the view 0 to be plus equal, let's say 10. Or let's actually make a global variable out of that. Let's say that's the camera speed or camera pan speed. So maybe we can also implement, like, if you press shift you can pan around more quickly. We of course will also want to add that variable to our globals. So let's do that. Camera pan speed equals 10. Okay, so let's continue with the other directions. We can basically just copy this 4 times, and we are gonna do VK left, we're also gonna do VK down and VK up. Of course here we have to change the direction, and here we will have to change to the Y position, up and down and minus. So this should be good. I think we can actually already test the game just to see if we are on the right track here. So we should be able to pan around. Oh yes, that is already working just like in every game you are used to. Of course we can also pan outside of the room. That's a restriction we will have to implement, but nevertheless I'm glad this is already working, so we can continue with the next step. So how could the restriction look like? Let's see, we have to add another condition. We want the view X view of 0 to be lower than the room width minus the view of the width view 0. So what does that mean? We don't want the X coordinate of the left corner of our view to exceed the room width minus the view itself. So that means the most right corner should not exceed our room, at least in theory. Of course the minus coordinates are a little bit easier to calculate. We can say the X view should be higher than 0 at all times, so we cannot go further to the left than our room. Okay, so let's apply the same conditions right here, just using Y view 0 should be smaller than room height minus view H view of 0. And for the up direction we can do it the easy way as well, just higher than 0. Perfect, and that's basically all we have to do. Let's check if that works. I cannot go further to the left than this, and I cannot go further up than this, which is great. So we are restricted in that way. We cannot go further down, also true, and we shouldn't be able to go further to the right, which is also the case. So we are limited to our actual world, which is exactly what I wanted to achieve with this segment. Okay, so let's get to the more complex part in my opinion, which is the zooming. And of course this is more complex because the zooming effect goes towards the 0, 0 coordinate of the view, which is on the upper left corner, but we kind of want to zoom in the middle. So this is the hard thing to achieve, and hard I mean in a double sense, because we're gonna use the hard in order to achieve what we want to achieve. So we're gonna take the object hard x position and we're gonna set that equal to the x view 0 plus the view width of 0 divided by 2. This will make sure that the object hard will be in the center of the screen at all times, no matter how far or how close we are zoomed in. We also need to do this with the y position, of course, so view y view plus view h view divided by 2. There we go. Now before we go any further, we need to make sure that all of this can only happen once the tile generation is over. Otherwise we are gonna have issues if we are dealing with the object hard, because it is required in the tile generation. So what we're gonna do is enclose this in an if statement, global tile generation equals false. Only then all of this can actually happen. Let's properly format this. Perfect. Okay, now that we have that, we can continue with our next if condition, which is gonna check for a mouse wheel, specifically a mouse wheel down. Mouse wheel down means towards your body, and therefore we will want to zoom out with this function. So what we want is to enlarge the view width and height of our current view, W view of 0, and we are gonna actually multiply this by about 1.05. Or let's make a global variable out of that too. Let's say camera zoom speed, and we will want to add that to our global variables. We're actually gonna have to make two different ones. Let's say that's the zoom speed out, which is 1.05, and we're also gonna have a global camera zoom speed in, which I'm gonna set equal to 0.95, and hopefully this will result in a smooth and not too fast zooming effect. So where were we? We set the view width times the global camera zoom speed, and we must also do the same thing of course with the height, otherwise we're gonna run into difficulties. So let's set that to the global camera zoom speed out, and of course we have to fix this one as well. There we go. So far so good. There's just one thing we need to consider. Oh geez, look at all the mistakes I'm making. Anyways, every time we zoom, of course the global hard position will have to change. And in order to not confuse the whole program, we need to make sure that our view actually adapts to the position of the hard. So that instead of zooming in towards the upper left corner, we're going to zoom in towards the heart, which is going to remain on its position. In order to achieve that, we're going to take the x coordinate of our view and we're going to set it equal to the object heart x position, and beware that we have to calculate the center of the view, which is of course minus the view width of 0 divided by 2, if you remember. We're also going to do the same thing with the y coordinate equal to object heart y minus h view divided by 2. And theoretically, at least in my head, this will actually work out. So now we're ready for our next if statement, which is of course going to be the mouse wheel up. And in here we need to do almost the same stuff, so it's probably wise to copy this over, and of course we want to multiply this with the global camera zoom speed in, as well as this one. And this is all we had to change, isn't it? I can almost not believe it. So testing our game, we have actually successfully managed to bind our heart object to the center of the screen. We can also zoom out and the heart will remain on the center of the screen. No matter how far we are zoomed out, we can still not exit the room. You can see here the room actually ends. We managed to get slightly beyond where we wanted to go, because of course it can jump into the minus area depending on our camera speed. Nevertheless, we still have one problem. Of course we can zoom in endlessly. It will never stop. It will just become bigger and bigger and bigger, and of course we want to stop that at a certain limit. The same thing we want to happen when we zoom out. Right now we can zoom out endlessly, though actually that is not a too shabby effect. Maybe if we could add some kind of a background instead of the gray. I'm not sure if that is possible. It's probably not. But nevertheless, let's try to restrict it at least somewhat. But nevertheless, let's continue with the coding. For instance, we still have to program in the WASD keys. Okay, so I think I actually thought of a solution to our little problem. First of all, what we want to do is add a condition so that we cannot zoom out further than the room width. So we're gonna say, and if the view width of 0 is smaller than the room width itself, then we can zoom out. If we zoomed out further than the actual room width, then we cannot zoom out any further. That is good. We can also add the same condition right here. We can say, and view view 0 is smaller than room width. Of course, we probably also want to add the room height, because theoretically we want the user to be able to have a world which is wider than it is high. So let's add the third condition, which is view view 0 is smaller than room height, and down here as well, and view view 0 is smaller than room height. There we go. So we already added some restrictions, but that will not prevent us from actually going to a corner and zooming out. We will still be able to see whatever the heck is beyond our actual room, and we want to avoid that with all of our forces. So what we're gonna do is add a bunch of if conditions right here. We're gonna say if view view of 0 is smaller than 0, we want to actually change that. We don't want that. We want to change it to 0 again. So whenever we go beyond the room to the left side, we want to change it to 0 again. We're gonna do the same thing with the view view 0 is larger than the room width minus the view width we currently have of 0. Close this off, and in here we're gonna change this to, of course, the same thing, room width minus view view. Oh geez, all the mistake, but you get the basic gist of what I want to accomplish here. So let's do the next condition. I'm actually gonna sort it right here. It's gonna be the y view of 0 smaller than 0. Then we want to set it to 0 again, just as we did previously, equals 0. And down here we can probably copy that and just exchange the x's with y's, and we want to change this to room height, of course, just as well as this one. And I believe, oh yes, we also have to exchange this. Sometimes it's just easier to write it on your own, otherwise you might forget to change something. So we have done it for the zooming out effect. We will still have to do it for the zooming in effect. So let's copy this over, and we are gonna add it below here. That should be good. And let's see, do we have to change something? Actually, now that I think about it, for the zooming in we might not even have to do it, right? Because there's no way we can zoom in outside of the board. So this is maybe code that is obsolete, and of course we don't want that. Yeah, I think with these adjustments we are ready to actually try it out. One last thing I want to do is, of course, also to add the WASD keys. Now, correct me if I'm wrong, but I believe we can just add an OR statement and say keyboard check, and now we have to add an ORD, which is, hold on, not W, it's D to go to the right, something like that. And we are going to copy this over and add it to each of those guys, just like that. Oh man, I just hope it's gonna be that easy. VK left is gonna be A, down is gonna be S, and up is gonna be W. Okay, this should work out. Now we're gonna save this document, and we see us back in the game. This wouldn't be a proper programming session without a bunch of rookie mistakes. For instance, I figured out that we cannot do it like this. What we can do though is to actually take this out again, and we are gonna add it to the next row like this. And here we're gonna add another AND statement and copy this over, and like this it hopefully will actually work. This now means either these two conditions have to be true, or these two conditions have to be true in order for the next thing to be executed. So I'm gonna change this for all of these lines, but there is one more thing which we have to change, and that is of course for the zooming in function. We don't want to have the same restrictions. We want the view width to be larger than the view width divided by, let's say, 10. So we can zoom in 10 times the original size. At least that's what I believe it means. Also, we want to make this higher than the view of 0 divided by 10. Okay, I think these are all the changes. As I said, I'm gonna change it for the other lines and we see us back in the game. Okay guys, here we are in the game. WASD is working, the restrictions are still working, and what I like the most is the zooming in and out. Of course we can still zoom in and out normally, but if we are at an edge, the image now gets corrected. You can see how our heart is actually jumping into the center of the screen, and the zooming out effect is a little bit different, so that we never really leave the room area except of this one tile size, which we actually can correct by just adding it to the restriction. That's probably something we can do, but that is fine-tuning. The basic idea is definitely working, and it will also apply to larger or smaller worlds, so I'm definitely happy about that. Well guys, that has been it for today's episode. I hope you enjoyed the coding session today. Let me know about the improvements and suggestions as usual. Don't forget to leave your likes. Have a great time, and hopefully I'm gonna catch you in the next episode.